Hello students, today let us learn one of the most important chapter in science. So that is chemical reactions and equations. Students, we have noticed so many changes around us. So I have listed some of the changes. So let us look into it. So one is rusting of iron, conversion of milk into curd, food is cooked, germination of seed, melting of ice, mixing sand and water, dissolving sugar or salt, chopping vegetables, and still many more changes that we have noticed around us. So these changes are classified as physical and chemical changes. So here, rusting of iron, conversion of milk into curd, food is cooked, germination of seed. So first four are chemical changes. And melting of ice, mixing sand and water, dissolving sugar and salt, chopping vegetable, or physical changes. So what are chemical changes? First let us understand what are chemical changes. So chemical change, it is a change where we do not get the substance in their original form. Chemical change is a change where we do not get the substance in their original form. Rusting of iron is a chemical change. So we do not get the iron back. After rusting, we do not get the iron in its original form. Conversion of milk into curd. After milk gets converted into curd, we do not get again the milk. Similarly, food is cooked. We do not get back the rice. So in all these changes, we do not get the substance in their original form. So such changes are classified as chemical changes. So what are physical changes? Physical changes are the changes where we get back the substance in their original form. So coming to the example, melting of ice. What happens when ice melts? It turns to water. Water can again get converted. We can get converted into ice. So melting of ice is an example of a physical change where we get the substance in their original form. And mixing sand and water. So we can separate it by filtration. We can separate the sand and water. So we get the substance in their original form. Similarly, dissolving sugar or salt and chopping vegetables. So in these changes, the substance do not change their properties. Even when the vegetables are chopped, vegetable will remain as vegetables. So the initial nature of the substance doesn't change. But in chemical changes, the nature of the substances changes. See, milk into curd or rusting of iron. So food is cooked. So the nature of the substance has entirely changed. So now let us learn these chemical changes in this lesson through different experiments. So we have three different activities. So first activity is burning of magnesium ribbon. Burning magnesium ribbon. So I have magnesium ribbon here. So this is magnesium ribbon. So I have taken a strip of magnesium ribbon and my experiment is very simple. So just I need to burn the magnesium ribbon. So now students, burning magnesium ribbon. So you can observe how brilliantly the flames. So you cannot look it with a naked eye. So we call it a dazzling. So in this experiment, so you can observe the evolution of gas. So during a chemical reaction, the changes that has occurred is evolution of gas. Evolution of gas. And the solid ribbon has changed or converted into powder form. So there is a change in state. Change in state. So these are the changes that takes place when the magnesium ribbon is burned. So now let us look into the another activity, that is adding dilute hydrochloric acid or sulfuric acid to zinc granules. Dilute hydrochloric acid or sulfuric acid. So I have hydrochloric acid here. I have got hydrochloric acid and have zinc granules. So now I am going to add this dilute hydrochloric acid to the zinc granules. So I have taken a small piece of zinc granules. So what happens when dilute hydrochloric acid is added to zinc granules? Zinc is a metal. So whenever acid is added to a metal, so hydrogen gas is liberated. Hydrogen gas, it is the most so I have added so slowly. So you can see the reaction. So the gas bubbles are rising. So the gas liberated here is hydrogen. Hydrogen, it is a highly combustible gas. So this is the activity. So whenever we add acid to a metal, hydrogen gas is liberated. So and if you touch the test tube, so there is a change in the temperature. So it will be little warm. Okay. So this is your second activity. And the third activity, so I do not have any materials for it. So just I will explain what it is. And the third one is adding potassium iodide to the lead nitrate solution. So adding potassium iodide, it is Ki to lead nitrate. So what happens? Lead iodide and potassium nitrate is formed. So these are the different activities, so where we can understand better the chemical reaction and the factors. This experiment, so we have understood what are the factors that determines a chemical reaction. So these are the different factors. So one is change in state, change in color, evolution of gas, and change in temperature. So these are the four factors that determines a chemical reaction. If there is a chemical reaction, if any chemical reaction has taken place, then you might have noticed either of any of the changes. So now coming to the chemical equation. So whatever the reaction that takes place, so we have to write. So first, so we have followed the reaction in the sentence form. So I am coming to the activity first. So that is when a magnesium ribbon is burnt in oxygen, it gets converted into magnesium oxide. So there are thousands of reactions. So if you write everything in the sentence form, so it becomes quite long. So we have found out the second simplest way to express the chemical reaction is the word equation. So writing in the words magnesium plus oxygen gives magnesium oxide. But so in this word equation, we are not able to identify the number of atoms that are taking part in the reaction. So now, for that, so we have followed the symbolic form of representing the chemical equation. So that is Mg plus O2 gives Mg2. So here magnesium plus oxygen gives magnesium oxide. So this form of expressing the chemical reaction is very simple and precise. So here the reactant always, so whenever you write the chemical equation, always, so in the left hand side the reactants are written by using the plus sign, and so in the right hand side the products. Here the arrow mark indicates the direction of the reaction. The direction of the reaction. So here, so we can easily identify the number of atoms that is taking part in the reaction. But if you observe the number of reactants and the number of products, so here magnesium is 1, magnesium is 1, oxygen 2 and oxygen 2. So here the equation is not balanced. So if the equation is not balanced, then we call it as a chemical equation. So we need to balance the chemical equation. Now let us learn how to balance the chemical equations. Before learning how to balance the equation, we must understand why do we need to balance the chemical equation. So during any reaction, the total mass of the product must be equal to the total mass of the reactant. So because we have learned the law of conservation of mass. So what does it say? So it says that mass can neither be created nor be destroyed. So balancing the equation is very important while writing a chemical reaction. So now let us learn step by step how to balance the chemical equation. So just follow these two steps, students, so you can easily learn how to balance the chemical reactions. So first step, so count the number of atoms on each side of the equation. So that is the first step. So what you have to do, so just count the number of atoms on each side of the equation. And step 2, only change the coefficient. We have to change the coefficient to balance the equation. So both left hand side and right hand side. So now students, let us look into the equation. So first equation, iron oxide or ferrous oxide. So when it reacts with aluminium, so the product formed is iron and aluminium oxide. Fe2O3 plus Al gives Fe plus Al2O3. So now write the reactants on left hand side and the products on the right hand side. So the number of atoms of iron is 2. Oxygen is 3 and aluminium is 1. So this is the number of atoms that is present in the left hand side. So right hand side. So iron is 1 and aluminium is 2. Oxygen is 3. Iron 1, aluminium 2, oxygen 3. So now both the atoms should be balanced. So that is our task. So it is just like a heat and trial method. So it is like mathematics. So balancing the chemical equation is like mathematics. So now, so how we can balance the equation? Say iron 2 and 1. So we have to multiply the iron atom with 2. When we multiply, so we get 2. So iron becomes, make it a 2Fe. So iron atoms are balanced. So next, oxygen is 3 and oxygen is 3. So oxygen atom is already balanced. So aluminium is 1 and aluminium is 2. So to make it aluminium 2, so multiply the aluminium with 2. So and multiply the quotient. You should not write here. So this is the wrong method. Only coefficient must be changed. Coefficient must be changed. So now Fe2. So right hand side 2. Oxygen 3. Oxygen 3. Aluminium 2. Aluminium 2. So the equation is said to be balanced. So now let us look into the other example. Sodium hydroxide plus sulfuric acid gives sodium sulfate plus water. So first write out the number of reactants on the left hand side and the product side on the right hand side. So left hand side, sodium Na, that is 1, oxygen 5, hydrogen 3, sulfur 1. Sodium 1, oxygen 1 plus 4, I have written 5. And hydrogen is 1 and 2. 1 plus 2. Hydrogen 1 plus 2 is 3. Totally, we have to add the reactant side. So in sulfur, only 1. So when you look into the right hand side, sodium is 2 and sulfur is 1. Oxygen is 4 plus 1. Oxygen is 5 and hydrogen is 2. So to make it equal, so we have to multiply the coefficient. So sodium is 2 here and sodium is 1 here. So first multiply it by 2 to make it 2. So when you multiply 2, the whole sodium hydroxide gets multiplied. Sodium hydroxide gets multiplied. So 2 NaOH. So 2 into Na. So 2 into O. So that is 2O plus 4. So it has become 5 plus 1, 6. When you multiply sodium hydroxide by 2, so what happens? Sodium has become 2 and oxygen is also multiplied by 2. And 2 plus 4 is 6. So totally oxygen has become 6. And hydrogen 2 and 2, 4. So here 3 plus 1. So we got 4 atoms. So now, so if you look here, so hydrogen is 2. Hydrogen is 2 and hydrogen is 4 here. So to make it 4, just multiply by 2. So when you multiply by 2, so it becomes 4. So hydrogen 4. So you are multiply the coefficient in the right hand side. So hydrogen is 4. What happens? So oxygen has become 2 and 2 plus 4 is 6. So earlier it was 4 plus 1 5. So now, so we have added 1 atom, so it is reduced. So oxygen atom is balanced. So sulfur is balanced. Sodium is balanced. So totally the equation is said to be balanced. So now the other equation. So hydrogen plus oxygen, so gives water. So we have known equation. So but oxygen atom is not balanced. So O2 is there and O1. So in order to make it 2, multiply with, so just multiply the coefficient. So now what happens? When you multiply H2, so 2 into 2, so it becomes 4. So hydrogen atom has become 4. So when hydrogen atom has become 4, so here also we multiply by 2, so to make it 4. So 2 into 2, hydrogen has become 4. So hydrogen atom 4, 4. Left hand side, right hand side. It is balanced. Oxygen atom 2, 2. So it is balanced. And students, no need to put the box or no need to write left hand side, right hand side. But while learning, so if you write, so you can easily identify whether the elements are balanced or not. Now let us look into another equation. That is, when methane reacts with oxygen, carbon dioxide and water vapor is formed. So now, what are the number of reactants on the left hand side? Carbon 1, hydrogen 4, oxygen 2. And on the right hand side, carbon 1, oxygen 2 plus 1. So totally 3. And hydrogen is 2. So now both left hand side and right hand side we must balance it. So if you look number 1, 4, 2, 1, 2, 3. So 1, 1 carbon atom is balanced. So hydrogen is 4 here, 2 here. So we can easily make hydrogen 4 by multiplying it with 2. So hydrogen becomes 4 now. So you have multiplied 2 here. So coefficient multiplied by 2. When it is multiplied, so oxygen is also multiplied. So oxygen becomes 2 plus 2 here 4. So already before multiplying we have 3 oxygen atoms. So now 1 is added. So now it has become 4. So now oxygen is 2 on the left hand side. So to make it 4, just multiply it with 2. So 2 into 2, now oxygen has become 4. So both left hand side and right hand side has become equal. Now let us look into another equation. So lead nitrate when decomposed, so it becomes lead oxide, nitrogen dioxide and oxygen. So first the number of atoms on the reactant side. Lead 1, nitrogen. See how do we read, students? PbNO3 twice. This twice should be multiplied inside the bracket, not by the lead. So this is 2 into nitrogen and 2 into oxygen. So 3 into 2. So oxygen atom 6 and nitrogen atom 1 into 2. So now on the right hand side, lead is 1, oxygen, count the number of oxygen atom, 1 plus 2, 3, 3 plus 2, 5. So totally 5 number of atoms are there. And nitrogen atom 1. Nitrogen atom 1. So now we need to balance the equation. See, observe both sides. Lead is balanced. Nitrogen 2 and 1. Nitrogen 2 and 1. Oxygen 6, 5. So first, if you see the reactant side, there is only one reactant. So first, let us just multiply it by 2. So I repeat, so it is an intent trial method. So what happens when you multiply it by 2? So when you multiply by 2, lead becomes 2. See, nitrogen we have 2 atoms already. When it is multiplied again by 2, it becomes 4. Oxygen, when it is multiplied by 2, it becomes 1. So now our task is to balance the product on the right hand side. So lead, to make it lead 2, multiply it with 2. So to make nitrogen 4, multiply by 4. So when you multiply lead by 2, so oxygen also has increased by 2. Oxygen atom also increased by 2. So when you multiply nitrogen by 4, nitrogen atom is balanced and oxygen atom has become 8. So 4 2s are 8. 8 plus 2 10 and 10 plus 2 12. So totally, so earlier we had 5 atoms. When we multiplied by 2 plus 8 plus 2. So now it has become 2 plus 8 plus 2. So totally the number of atoms has become 12. So both left hand side and right side has balanced. Now let us look into the one more equation, that is silver chloride. So AgCl, so it decomposes to silver and chlorine. So silver both sides 1. So if you observe the left hand side, silver and chlorine atoms are 1. So in the right hand side, silver atom is 1 and chlorine atom is 2. So just multiply the chlorine atom with 2. When you multiply the chlorine atom with 2, so chlorine atom is balanced and silver is also multiplied by 2. So now silver is 2. So in order to make it 2, again multiply by 2. So 2 into each. So the whole equation is balanced. 2 Ag, 2 Cl. So Ag 2 and Cl. So now let us look into the another equation. So potassium plus water is potassium hydroxide plus hydrogen. So observe the number of hydrogen 2 here. Potassium is 1 and oxygen is 1. So in the right hand side, so potassium 1, hydrogen 2 plus 1, 3 and oxygen is 1. So to make it balanced now, so multiply the coefficient. So hydrogen is 3 here and oxygen 1. So oxygen atom is balanced. So multiply this hydrogen by 2. So when you multiply by 2, so hydrogen atom is become 4. So when you multiply by 2, so hydrogen atom has become 4 and oxygen atom become 2. So 1 plus 1, so it has become 2. So in order to make it 2, the oxygen atom should be multiplied by 2. When you multiply by 2, what happens? So potassium is also multiplied by 2. So potassium becomes 2. So here also multiplied by 2. So potassium is balanced. So hydrogen, what happens here? So 2 into O, 2 plus 2. So that is one atom has increased, so it has 4. So hydrogen atom 4 and 4. And number of oxygen atom 2. So 1 into 2. So both left hand side and right hand side, so the products and the reactants number of atoms are equal. Now let us look into the one more equation. Sodium metal, when it reacts with water, sodium hydroxide and hydrogen is 1. So number of atoms in the reactant side 1, hydrogen 2, oxygen is 1 and sodium is 1, oxygen is 1 and hydrogen is 3. So now let us try to balance the equation. So first number of hydrogen atoms. So let us multiply by 2. So 2 into 2 becomes 4. So oxygen has become 2. So 1 into 2 is 2. So now multiply the equation by 2. So when you multiply the equation by 2, so sodium becomes 2. So oxygen is 3 here. So oxygen is 2 here. So 1 into 2. And hydrogen is 2 plus 2. So totally hydrogen atom is 4. So now if you observe, So sodium is 1 multiplied by 2. So sodium 2 on both sides. So hydrogen 4 on both sides and oxygen 2 on both sides. So the equation is said to be balanced. So now let us look into the one more equation. Barium chloride plus sulfuric acid gives barium sulfate plus hydrochloric acid. So number of reactants on the left hand side: barium 1, chlorine 2, then hydrogen 2, sulfur 1 and oxygen 4. So barium 1, sulfur 1, oxygen 4, chlorine and hydrogen. So barium balanced, then chlorine is not balanced. Just observe, chlorine is 1 here. So just make it 2 by multiplying 2. So now hydrogen becomes 2. So hydrogen is 2 here and chlorine is 2 here. So barium 1, so sulfur 1 and oxygen 1. So now left hand side and right hand side, so both are equal. Till now we have studied the factors that determine the chemical equation and how to balance the chemical reaction. Now let us study the different types of chemical reaction. So what are the different types of chemical reaction? One is chemical combination reaction, chemical decomposition reaction, chemical displacement reaction, chemical double displacement reaction and redox reaction. So now let us study in detail about these 5 types of reaction. So first let us study what is combination reaction. So by the word we can understand what is combination. So combination reaction, so it is a reaction in which 2 or more substances combine together to form a new substance. So such a reaction is called a combination reaction. Let us look into the examples. So one, calcium oxide and water combines, we get calcium hydroxide and heat energy is liberated. When we add calcium oxide to water, so calcium hydroxide is formed. So here we can observe 2 substances combine together to form one new substance. That is very important. Entirely a new substance is formed with the release of energy. So now the other example. So hydrogen and oxygen combine together to form water with the release of energy. So hydrogen and oxygen, 2 atoms of hydrogen and 1 atom of oxygen, so combine together to form water. So here 2 substances combine together to form one new substance. So such a reaction is called as combination reaction. So now let us look into the second type of reaction. So that is the decomposition reaction. So decomposition reaction, it is a reaction in which a single compound breaks up into 2 or more products or substances with the absorption of energy. So without absorbing energy, no substances decomposes or breaks up. So by absorbing the energy either in the form of heat, light, electricity. So when the energy is absorbed, so this compound or the reactant, it breaks up into 2 or more products. For example, water. So when it is subjected to electrolysis, so it is separated into hydrogen and oxygen. So you can observe water is decomposed into hydrogen and oxygen. So the other example, ferrous sulfate. On heating it, so it is decomposed into ferric oxide, sulfur dioxide and sulfur trioxide. So a single compound, by absorbing the heat energy, it has decomposed into 2 or more products. So such a reaction is called as chemical decomposition reaction. Now, the third type of reaction is displacement reaction. So, what is displacement? So, displacement is nothing but the change of place. So, change of place. Opposite of place is displace. So, we can understand with the word. So, here what changes? See, it is a reaction in which more reactive element displaces the least reactive element from to form a compound. So, example, when you dip iron nail to a copper sulfate solution, when iron nail is dipped to a copper sulfate solution, so iron sulfate and copper is displaced. Iron sulfate is formed and copper sulfate is displaced. So, similar example, when zinc is added to copper sulfate, zinc sulfate and copper is displaced. Zinc sulfate is formed and copper is displaced. See, here iron is more, in the first example, iron is more reactive than the copper. So, in the electric wires, we never use iron, we use copper. Why do we use copper? Because iron is more reactive. So, we use copper. So, when compared to both elements, iron is reactive. This iron displaces the copper. Similarly, zinc is more reactive than the copper. So, zinc displaces the copper. So, such a type of reaction where the highly reactive element displaces the least reactive element is called a displacement reaction. So now the other type of reaction is double displacement reaction. So what is this double displacement reaction? So it is a reaction in which there is a mutual exchange of ions between the reactants. So mutual exchange. So give and take. So there is a mutual exchange of ions between the reaction. So example, sodium sulfate and barium chloride. When it reacts together, so you can see the exchange of ions. Barium has taken the sulfate. Sodium has taken the chloride. So barium sulfate and sodium chloride is formed. So here barium sulfate remains as precipitate. So just if you take a 5 gram of sodium sulfate and add to the barium chloride solution, so barium sulfate and sodium chloride is formed. Here barium sulfate is the precipitate. So you can easily remember. So when you dissolve the salt, sodium chloride is nothing but salt. So when you dissolve in water, so it is a homogeneous solution. So okay, it is not a precipitate, but barium sulfate remains at the bottom of the test tube. It never dissolves in it. Okay, so this is the precipitate. So similarly, barium chloride with aluminium sulfate. Barium chloride with aluminium sulfate. So it forms aluminium chloride and barium sulfate. So aluminium has taken the chlorine and barium has taken the sulfate. So there is mutual exchange of ions between the reactants. So such a type of reaction is called as double displacement reaction. Now coming to the last type of reaction, Redox reaction. So this Redox reaction is formed by two words, one is oxidation and reduction. So now let us learn this redox reaction with the example. So when copper oxide is added or passed with hydrogen gas, so copper and water is formed. When cupric oxide is passed with hydrogen gas, so copper and water is formed. So in this reaction, you can see hydrogen is getting oxidized. So hydrogen is gaining the oxygen, whereas the copper oxide is losing the oxygen. So copper oxide is becoming copper. So here you can observe the oxygen atom is getting reduced. So here copper oxide is getting reduced. So it is a reduction. So what is reduction? The loss of oxygen. The loss of oxygen is called reduction, whereas the hydrogen, so it is gaining oxygen. The process of gaining oxygen is called as oxidation. So in this example, so both oxidation and reduction takes place hand in hand. So here in this example, one of the reactant is getting oxidized, whereas the other reactant is getting reduced. So such a type of reaction is called as redox reaction. Similar example is there. So zinc oxide and coke. So when zinc oxide and coke is added, so we get zinc and carbon monoxide. So in this example, zinc oxide is getting reduced to zinc. Zinc oxide, which is getting reduced, zinc oxide is getting reduced to zinc, whereas carbon or coke is getting oxidized. So this is also an example of redox reaction. So these are the 5 different types of chemical reactions. Study the various effects of oxidation in our everyday life. So one is corrosion. So what is corrosion? So let us look into the examples first. So one is rusting of iron, the other one is black coating on silver, and the other one is green coating on copper, and still many more. So usually the railway track cracks, iron bridges. So big iron bridges also corrodes. We say corrodes. So to overcome or to prevent from corrosion, so we spend enormous amount of money. So even the ship body, which is made up of iron, also corrodes. So to prevent from corrosion, so we used to paint or we used to galvanize. So the other effect of oxidation is rancidity. So what is rancidity? So whenever the food is cooked with fat or oil, when it is subjected to oxidation, so there is a change in the smell or taste. So whatever the food that is cooked with the fat or the oil, and when it is exposed, so when it is exposed, it gets oxidized. So it gives a foul smell. We say it rancid. So and there will be a change in the smell and the taste. So this effect is known as rancidity. So in order to overcome the rancidity, so usually nitrogen gas is flushed in the chips packet to prevent from getting oxidized. So when you purchase any chips packet, so like Lay's or Kurkure or whatever it will be, so it will be flushed with nitrogen gas. So nitrogen gas is an antioxidant. So it prevents the further oxidation. So there will be no change in the taste or smell. So it will be safe for some long time. So we can use it for some long time. So usually nitrogen gas is flushed in the chips packet. So till now we have studied the various types of chemical reactions and equations and their effects. So if you like this video, please share and don't forget to subscribe my channel.